Welcome to the second in our series of lessons about the binary search tree. This lesson will be very easy for you if you've been listening to what we've done so far. In this lesson, we'll confirm how to identify that a tree is a binary search tree, how to describe adding data to the tree, and explaining how to find data in a tree. These are all things that can come up in the exam, and these are easy marks to get. Supposing they show you a picture of a tree in the exam and they ask you to describe it, which is quite likely, you've got to think, is it a tree? Is it a binary tree? Is it a binary search tree? So what about these? These are some typical sort of images you might see. For any one of those, can you describe what it is? Let's have a little think about that. Some of those images are not trees at all. That is not a tree. It doesn't have a root. It's not in a hierarchical structure. This is actually what we call a graph or sometimes a map, and we'll be looking at those in a couple of weeks' time. Other images are not binary trees, so you can see that there are the node with 7 in it has got 3 pointers, so that's not a binary tree. These are binary trees, but they're not binary search trees. Can you see why not? Because the data hasn't been added using the left-right rule. You can see that the second tree has got duplicated values in it. That's okay, but it's not a binary search tree. In fact, none of the examples that I showed you at the start were binary search trees. This is a binary search tree. We've seen it before. And I just want to very quickly go through how you would deal with questions that they might ask about a tree of this nature. They might ask you to make a tree from a set of data values. I think that's unlikely, but you do know how to do it anyway. They might ask you to add data to a tree in the right place, explain the steps to find a value or how to prove that a value is not in the tree. They might ask you how many operations those activities take. So in this case, this is a familiar tree we've seen before. They might show you a tree in the exam and give you a value and ask you to add it to the tree. Read the question carefully. They might ask you to just draw the value in the right location. We've seen this before. Or they might ask you to describe it, in which case you'd say, I'd start at the root. That has the value 8. 9 is bigger than 8, so I'd go to the right. 9 is smaller than 10, so I'd go to the left. There is space to add it there, so I would add it. So if you just write the steps down. Similarly, and we've done this before, but I just want to explain how you'd write it in the exam. Supposing they showed you a tree and asked you to describe or show how you would find a value in the tree, like 4. So one thing you could do would be to draw the arrows onto the tree to show the route that you would take. And I think you should also probably describe in words what you should do. Read the question carefully, but in this case, so 4 is smaller than 8, so I'd go to the left. 4 is bigger than 3, so I'd go to the right. 4 is smaller than 6, so I'd go to the left. And then I found a node with 4 in it. And last but not least, supposing they asked you to find a data value that's not in there, or how would you prove that this data value is not in the tree? And again, you could draw the arrows, or you could describe the steps and say, and we'd expect to find the value in this instance off to the right of 14, but it's not there. And if it's not there, it's nowhere in the tree, because that's the only place that it belongs. Okay, so that was a very quick scamper through the kind of things that might come up in the exam. I'm hoping you're feeling quite confident about it, because these questions are not that hard once you get the idea with trees. So I wanted to try a test where everybody will perhaps create a slightly different tree. So write down the colours of the rainbow, if you can remember them, and make them into a binary search tree. There are many different ways of doing that, so I'll leave that up to you. Draw the tree on paper. You don't have to scan it in or anything, because if you go to tree test 4, I ask you questions to describe the tree that you've just created. So have it on paper and open tree test 4 and answer questions about the tree that you made. This is the second of our presentations about binary search trees, and in the third one we'll create a binary search tree in a 2D array, which is very similar to what we've already done about trees in arrays. So see you after you've completed tree test 4.